Today I would like to talk about an ETFE, a material that is very popular in the recent structures in the world of tensile engineering. ETFE is more or less a plastic material which is very lightweight. For architectural applications, it comes within the thickness of less than 0.5 millimeter. It's UV stable and very resistant to weathering, aging, and many chemicals. And very good news about this material is that it's 100% recyclable. From structural point of view, the material is very light because it's thin, and it delivers tensile strength that is good enough for structural applications. But besides its lightweight, the most impressive advantage that ETFE as a material has that it's flexibility. It means that ETFE can be used in the projects that are completely flat or they are curved, as you see on the picture, to negative Gaussian curvature. These shapes we usually know from the typical fabric structures, but also ETFE can adapt these shapes. But most important and most often is the appearance of the positive Gaussian curvature shapes, which are natural for inflated structures. ETFE, because it's transparent and very flexible, it's very suitable for, especially for inflated cushions applications. From the projects that we have recently realized, the simplest way how to use the ETFE is in the form of flat, transparent structure. This transportation project in Brussels is cable-supported single-layer ETFE. And the purpose of the ETFE there is not only cladding, but also load-bearing. It's single layer, but below the structure, an additional layer of PVC triangles is added to make the architectural appearance more maybe nice and to deliver also some shading. But ETFE itself doesn't have to be only transparent and clear as you see on the picture, but can be also printed, as is shown for this transportation project in Poland. And the possibilities of printing are limited just by the fantasy of the designer. So in this case, a single layer ETFE structure for the foil fulfills not only the load bearing and cladding function, but also an architectural street art. Projects from ETFE in a smaller scale, besides it's printed, can include also some technology. When you will have a look more detailed on this picture, the little brown islands in the facade are not the printing, but actually integrated PV panels. So this facade structure includes also the production of electricity, and all these functions are connected in the film that is 0.25 millimeter thick. From the curved projects, I think this is a very outstanding example. It's an US embassy in London, and it's a single layer ETFE which is stretched over the steel structure and it's stabilized with an edge cables. The function is purely aesthetic and architectural, but as you can see, the curvature of the system and the complexity of the whole facade is dominating the whole architectural impression of the building. The most usual application of ETFE is in inflated, multi-layer inflated structures that we are normally calling cushions. As you can see, these cushions can be mass produced in a certain shape, or you can deliver structures where you cannot find two cushions that are similar or have a similar geometry. Good news is that with increasing complexity of the final shape, the complexity of the production and fabrication of the ETFE structures it's not increased or increased only a little. From this point of view, the very specially curved and architecturally pleasing structure is, from the financial point of view, competitive to very flat and simple structures. So one of my favorite projects is this commercial project in St. Petersburg, Russia. And on this project, it can be proved that cushions are not very soft and flexible structures like they look, but they are able to withstand very drastic, I would say, the winter climate that Russia is famous for. And also it's able to withstand the high loads of the snow, for example, the very low temperatures in the winter, and also high wind loads, because this structure is exposed to the sea or to the lake, and every structural engineer knows that in such an exposition the wind loads are very high. And by this structure it can be proven that ETFE is a reliable construction also for very demanding environments, like is the case of this project. ETFE cushions are very often delivered in multi-layer or multi-chamber constructions, where the inner layers can be used for various purposes. While the top and bottom layers are used mostly to carry the loads, the inner layer can, for example, be printed to deliver shades, or in case of this construction in Munich, it's used to support the photovoltaic panels and generate the electricity. Besides generating electricity, the large density of the panels offer also some shading. And last example that I have for this presentation is this facade, which is maybe on the first sight not very interesting structure, but with inclusion of artificial lighting, it becomes interesting after the sunset. And it can be, as well as printed ETFE, it can be interesting in many different ways. And the final architectural impression is limited only by the fantasy of the designer. So I hope you like this small excursion to the world of ETFE and current work of Taiyo Kogyo.